Hello, everybody. Welcome back. This is the second live class in the course on groundwater modeling. Um, I'm keeping my introduction very short from my IHE side because we have our guest here, Sol Montoya from Hatari Labs, who will give another great course. So enjoy. Sol, the floor is yours.
Okay, thank you, Hans, and once again, thank you for this opportunity. I hope that the video and the audio is all right. We will follow the same procedure of the yes one, yes two, because I want to know which is the development of how you are dealing with the course. Let me check some things first. In this webinar, we are going to work with grid options. And how is it? So on the course content, we are going to work with, sorry, that because I want to generate a grid on model views. So open this. I will use Opera and close this. Okay, so we will start with some theory behind. I have explained that latest on the latest class. On the class before, this is the, I mean, and this is for this also has some challenge when you are using GDAL and NumPy as well. It's the same challenge. Why? Because when you use the Cartesian method, you actually start from this, and all the x-axis on the positive direction goes in this direction, and the y-axis goes in this direction. While if you are dealing with a grid with a NumPy array, or like any matrix of row and columns and layers, actually the rows goes in this direction, yeah, and the positive columns goes in this direction. Okay, so this is the main, when we are working with a groundwater model, actually we are working with an array of rows and columns that are translated into a space and into a coordinate. Okay, but in the end, what we are dealing is with array of rows and colors and layers. Okay, so the origin of the rows and colors and layers is this point, while on the geospatial analysis is this point. Okay, you have to keep in mind that. Mhm. So when a new model is created, we need to define an initial grid. An initial grid box gives the opportunity to specify a grid that is universally depends on rows and columns. Okay, that's not entirely true. This is in ModFlow 2005 and ModFlow 2005 and ModFlow 6 on the version Dix. But okay, let me check if I have this. I can show you this. Oh no, I don't. I'm not signing. But you can do with ModFlow 6, you can do unstructured grids, and then you can do triangular grids and Voronoi grids as well. Okay, so everybody, please open a new ModFlow model. So let's go to Model Muse, Model Muse, Model Muse. Okay, and here let's create a new ModFlow model next. Okay, I just remind you that this part is almost in, how to say, sorry, is almost um, informatory. Let's say it's general information. Okay, it's actually no. So it's model 1 class 2. The PSG, well, let's see, Hans, which is the, or anybody, which is the UTM, which is the UTM 84 of Amsterdam. So it will be 326 something. Okay, well, let's say, I don't know. Okay, somehow I cannot. Give me a sec.
It's 32631 Sol.
631. Okay, brilliant. Thank you. Yep. So this is, and then we are going to work in meters and seconds. Okay, let's type next. Okay, so I hope that everybody is here. Just to remind that here you can work by default. You are working Modflow 6. You can work in any other grids as well. Okay. Let's see. We are going to work with 15 columns, 15 rows, one layer. And then this is the refinement of 500 and 500. Great. So there you have. And then,
so can you improve your volume a little bit?
Can I improve my work? Sorry?
Your microphone, that we can hear you better.
Okay. Yeah.
Thanks.
Let me check this. Do you hear me better now?
Great.
Yeah. Okay. Yeah. Okay. So here we have your. Yeah, we are going to work with only aquifer. And it will be from 0 to -10. That's all right. So please check this. Okay, we are working with a grid of 500 by 100 meter, 500 by 500 meter. I mean, in your local area, in 500 meters can happen a lot on groundwater. I mean, you can have wells, you can have drains, you can have contaminant sources, and so on. So, I mean, will be 500 meters right for if you are dealing with a local scale, I mean, on the scale of a town. No, maybe not. But if you are dealing with a region, I mean, like if you want to model a province, or like you want to model a state, yeah, maybe you deal with 500 meters, with refinements of 500 meters and refinements of maybe 5,000 meters. Okay, so that's why you get, like, for example, you can have, and maybe you can work with column width of 5, or you can work in this case of column width of 500. Okay. I hope that everybody is here right now, and let's go to finish. Okay, so here we have, and this is our model. Great. So here we are. So we have 15 columns, 15 rows. That's why this thick line, this thick line is divided by this in this side, because actually are 10 columns plus 5 and are 10 rows plus 5. Okay, great. Okay, great. Okay, so if you are here with me, please type yes 1. If you are here with me, please type yes 1. And really thank you for the people that has say where you are connecting. So we have people from Sweden, Tanzania, Saudi Arabia, Netherlands, Mexico, France, Syria, Bolivia, Ethiopia, Canada, Mozambique, Iran, Spain, Congo, more from Mexico. And that's it. Okay, and then we have such a great response. So okay, so we can continue with our model. with our course. Great. So we can, okay, now we are going to work with these options that there are the options for the grid. Okay, there are options in Model Muse that are great if you want to define your own grid. Okay, so here I'm going to make a zoom on my grid. That's why we have, in this case, we have few columns and rows because we want to play around. Okay, well, first, what is this option? This option is an option to delete, okay, to delete separations. Okay, how does it work? It's like this. If I type here and I press it, for example, on this line, these two rows will be joined in a single row. Okay, if I press in this vertical line as well, these two columns um, will be joined in a single column. Okay, so if I press Control Z, I can go back. So please do that and then type yes to. Okay, so this option is an option to delete this, to delete lines. Okay, it's not, I mean, it should not be seen as an option to delete shouldn't be seen as an option to delete rows, because actually what it makes is to join rows. Okay, are you here with me? Please type yes to. Great. Okay, then we have people from Chile, from Syria, from Colombia, Morocco, Netherlands, and Nigeria, and Algeria. Okay, great. So you are doing great. Okay, as I told you, if you type Control Z, is the undo option, and as well, this same undo option appears here. Okay, okay, so appears here. Also from Nicaragua, Uruguay, Brazil, Uzbekistan. Wow, such a great audience. Okay, so this is the delete option. Oh, okay, if you want to join columns or join rows, you can do that, and then Control Z, you can go back to the beginning. Also, if you want to move this, to move the line, you can also move one line, or you can also move a specific column or a specific row. This is if you want like that the cell will be exactly there. For example, if you have a well here and then you have, for example, you can do it as well, okay? You can do, oh, I want this grid, because I'm not such interested what happens here. I want more discretization here. You can do it manually, okay? So we have also people from Ecuador and Philippines. Okay, however, this is not very practical. Okay, I remember that in my early years on groundwater modeling, I did that. Okay, but lately I haven't used this option on a long time. Okay, but the option is there. I mean, the tools are the tools in Model Muse and any other API or groundwater modeling software are tools, and the tools tools are tools that helps you to conceptualize a continuous system, a groundwater flow system, into a numerical construction. Okay, so actually you can use whichever tool it is available as long as it fulfill its goal. Okay, so don't be restricted on something, because like as I told you, this topic of numerical modeling is a kindly of a lonely work. I mean, usually when you're doing your master thesis, you have like an advisor, I mean, a meeting with your advisors once a month, okay? Or if you are working, like you are dealing with another people that knows something about groundwater modeling, but mostly you are by your own. So, and then this is nothing good in the end. I mean, there should be more groundwater modelers. but usually you are on your own, so you that also give you the freedom to use any tool that actually will do the work. Okay, and we have people from Algeria and India as well. Philippines, I guess. Yeah. Okay, so this is the tool where you can move the moves a column, change the thickness of columns and rows. Okay, so and this is also another tool that this is more practical. This is a tool that this one inserts more columns. For example, I will insert two columns here, and then I will insert two rows here, and here I have a new refine. Okay, this tool is practical. I mean, I have used this tool more often than the ones that move. Okay, so please do that. Create your own, like divide a cell into 9 and type yes 3. And we have also people from Pakistan and Djibouti and India. Okay. Okay, so do this refinement and type yes 3. Okay, great. Then what is next? Okay, something that can be done with okay, we can do um okay, this we have done that, but we have done that manually. Okay, and there is a tool that can improve this, like is subdivide grid cells. With these subdivide grid cells, we can do it more automatically. Yeah. So we can select any four cells. Okay, and with that we can say, okay, we have selected cell from row 12 to 13, from column 12 to 13, from row 13 to 14. Okay, and then we can decide, okay, I want this to be refined in 4, and as well for the on columns, on the 4 on rows. If we type okay, we will end up with 8 more columns. Well, in fact 7, because it was 6, because there was 2 columns before. But in the end, we will have 8 columns here and 8 rows here, because we have divided each cell into 4. Okay, Control Z. I will do it again. So I will select any 4 columns. You can select even more. I mean, and then you say, well, I want this to be divided, that each column and each row will be divided into 4. And then that's it. If you are here with me, do it and type yes 4. Okay, so this actually help us to do specific refinements. This one also, I want to do, this one allows us that the cell will have a certain size. Yeah, but the topic is that actually, for example, if I do this, so if I select to be 200. I will do this by myself because I have never used this one. Okay. Okay, so I say that each row and each column will be 200. Actually, it gives 200 to the thickness, but however, it affects the model extension. So I say actually the border is shifted some meters to the right and some meters to the bottom. Yeah, and this is maybe it's not desirable because maybe you have already defined your model area. So I will just type Control Z, because there is this option. I haven't done it. Oh, I haven't ever worked with that. Okay, there are people from Indonesia as well. Okay, so what is next? And this is what is I don't know if any of you have experience with Visual Mode Flow. But in those days, on Bison Node Flow, the properties were um, related to the cell. I mean, you define that in each cell, whether it's a hydraulic is a boundary condition or has some hydraulic parameters. However, here in Model Muse, the properties, the cell, the objects are over X are superposed to the cells. Okay, so what does it mean? That you can have here your river, you can have here your river, your basin, or whatever, but the grid can be independent to the spatial objects. Okay, so what does I mean? The best example of this is that we can rotate the grid. So let's rotate the grid. So here we can rotate the grid. So please rotate your grid and type yes 5. Okay. And then I will ask something on the chat. They say why we have to rotate the grid. Okay, so if anybody can give me the an answer on that, yeah, why we have to rotate the grid? Or when do you rotate your grids? Okay, for example, if you have a basin like this, I do just me. This is your basin. If you see, okay, this basin has like an axis of symmetry or like it's oriented more in this direction and this direction. So it will have no reason why you have your grid in this direction. Okay, because this part and this part will be inactive, so you will have a lot of cells that you have already defined, but they won't be where you are making any calculations on that. Okay, and let's say like Javier says, to couple with your study area. Okay, for example, this is in the case of this basin, so where you rotate. For example, if you have a preferential flow, for example, you have a leaking from a tail dam, and then you know the direction of the leaking. Actually, you will rotate your grid in order to match this direction. Okay. Okay, so these are some reasons, and there are many reasons why do you rotate. Okay, in this case, okay, so I will delete this. In this case, the rotation is mostly discretional by the user, because you say, okay, I want this to rotate. For example, this is an angle that I want, but you can also specify the rotation going to a grid and then specify grid angle. Everybody goes to grid and specify grid angle. And here you say 30. If you tap OK, and this will be the grid with 30. Okay, I mean, let's see. Okay, I will explain again this topic of the rotation. Okay. So yeah, I will. Zero. Okay, this is unrotated. This is an unrotated grid. For example, yeah, I have a basin like this. Yeah, okay. And this basin, if I use this grid for this basin, all of this part and all of this part will be inactive. Okay. Yeah, it will be inactive. Why it will be inactive? Because is not in the active part of the hydrogeological basin. Okay, so you will have this will be active and this will be inactive. But then you are wasting here. You are wasting cells, because actually these cells that are inactive are cells that will be on your model construction. You won't compute them, but they will be on the matrix as inactive. Okay, so if you want to optimize, you rotate your grid in order to have, and then, well, in the rotated version, this one has to be closer here and this one has to be closer here to maximize the number of cells that are inside your active area. Okay, really? Yeah, so this is the reason. So here I will delete this, and then to be on your, and the grid angle is 30. Okay, great. So that's why you rotate grid, and that this was possible on with ModelMuse. I don't know if any commercial software do this, maybe, yeah, but on the previous versions of ModFlow, of Visual ModFlow, on year 2000 or 2008, something like that, it was not possible to do. Well, the rotation is related to the flow direction. There are many things that can depend on the rotation. Could be the flow direction, could be the basin shape, could be any boundary condition that you want to reflect. Okay, this is discretional to the groundwater model. Why you will rotate? Because you can also do the model as I told you on the XY grid, but an unrotated grid, but this it really depends to you. Okay, so let's continue. Okay, so now what we are going to do, we are going to use the no grid option. Okay, so let's close this. If you want to save, you have to type yes. Actually, it's not necessary, but this is the process to save. You type yes, okay, and then, for example, you can place it into a folder. I strongly recommend that you, for example, you say exercise 1. Why you create a folder to store your model? Why? It has a reason. Yeah, and the reason is, yeah, and the reason is that, I mean, you at this time you are just storing a GPT file. Okay, but most probably in this folder you will also run your model, and then when you run your model, you will end up, for example, with 15, maybe 16. If you have another version, but you will end up with a lot of files. Yeah, because ModFlow creates a lot of files. And then if you are not in a separate folder, those files will join, for example, with your shape files, with your rasters, and so on. Okay, so this will be exercise 1. Okay, and in my case it says that ModFlow 6 cannot be found. Okay, and this reflects that here. Okay, let's see if I have ModFlow 6 installed. Oh, I don't have. Okay, here I have. Do you remember that on the latest course I didn't have it and it was kind of slow? Well, now I have it, so I will. This is the process following the tutorial. Control C on the AP, Control V, and then here I extract here. Okay, and here on ModFlow 6. Okay, this is also very important to mention. The bin are the executables, and these are the executables in Windows. So this is the main executable of ModFlow 6. Okay, the docs are the papers of ModFlow. Okay, and then if you want, and as I told you to anyone, If you have further questions, everything is on the paper. So if you want to know why you have to do this parameter, or why, which will be the value, or how this parameter works, and so on, it's on the papers. And well, on Moldflow 2005, it was much clearer because there was only one paper, but on Moldflow 6, they end up with this. And to tell you the truth, this and this are new. Okay, I have not read them, but the others I have read them because for me it's important to know how does it work. Okay, there are some examples, and the papers are related to these examples, and this is a well. Um, on a positive construction, the USGS can do it more, can do it better, these examples, because sometimes they are very basic, or like, for example, you have it that the aquifer is always confined, or like the geometries are very rough, so you don't get the idea that you are dealing with an aquifer. Or for example, there is a the main one was a seawater intrusion model where the island is a square. So um, for me, in order to conceptualize an island, I cannot see that as a square. No, I have to see some kind of a regular shape. Okay, but these are some examples that are also described on the papers. Okay, on the doc file. And these are for the, if you want to compile, for example, if you want to compile in Windows, in Mac, in Linux, and so on. Okay, and for example, to tell you the truth, this one and this one are also new, and there are some utilities that are some budget and some converters. But this is the to compile the utility. Okay, so let's start again. So here, Model Muse, we are going to work with Model Muse. Okay, we create a new Moldflow model. Next. We're not going to say nothing here because we know that this is only declarative. So next. And here, what we are going to work is with the no grid option. Okay, do you see that? The no grid option? Okay, so here, this is the no grid option. And what you see is something completely blank. Okay. And there are some questions. So I say inactive cells, do it some more processing time. Actually, I haven't tried that. I mean, I haven't tried. So how much is the computation code? But actually, if you are working with a lot of inactive cells, at least your output files will be bigger, and then it will take more time to create all the output files. Okay. And about the domain, if you're working with regional groundwater modeling, by sure you're going to work with UTM coordinates. Okay. So what we are going to do that right now, what we are going to do is we are going to create a grid, but this grid will be based on the grid will be based on a shape. Okay. But before doing that, I go to Moldflow program locations, model program locations, because I have to link my executable of Moldflow 6. Here it is on red, so I just go here, go to my C drive, go to my WRD, go to my MF 6.1.1, my Bing, and my MF6, and then actually recognizes that this is executable, and it became white. Okay. Okay, this is for me because I haven't done my tutorial, so actually I have a partial installation of Modflow, and I hope that for you have fulfilled all the tutorial, and then you have your Modflow 6 installed. Okay, so just type okay. Yeah. What is next? Okay, we are going to define a polygon. here we are going to define a polygon, yeah. Okay, this is a polygon. If you have defined your polygon, please type yes 6. Okay, great. Then we are going to use this cell size in order to define the grid. So here we are going to use the grid cell size. In my case, for example, it can be different to you, but here I have like 50 kilometers, okay? So if I have 50 kilometers, let me say that I want 50 kilometers, I want 100 cells, so actually 50 kilometers, if I divide it by 100, I will have 500. Yeah, let's say that I will use 2000, a grid cell size of 2000. Okay, great. Then I can change the object line. Why not? And that's it. Okay, so just to set the grid cell size and change color. Okay, that's everything that I will do. Okay, I cannot put 150 meters because it is possible, but the grid will be very dense. Okay, so here is 2000. Okay, and this type okay. Here is 2000 and just type okay. Yeah, and nothing will happen. Okay, why? Because we have defined that this object actually define the grid, but we haven't generated the grid. I mean, there is there is two phases. First, you define which objects will generate the grid, and then you generate those grids. Okay, okay. So what we have done is just define the object, and then if we go here, we generate the grid. And for example, in this case, let's see, and I will show you what will happen if I don't calculate the grid automatically. Is do that, it does that. But what will happen, generate grid, if I do calculate the angle automatically? It actually shift the axis in order to maximize the area of the maximize the active area. Okay, if you are here with me, type yes 6, yes 7. Okay, so and something great about Model Muse is that we can define the grid cell size anytime. So what does it mean? Let's say, okay, maybe 2000 uh, was too few. I want more a better refinement on my grid. So I just do double click with the red arrow. I do double click on my basing, do double click, and here I just type instead of typing 2000, I just type 500. Okay, so okay, and then once again I do okay, and here I have a denser grid. Okay, but now what I'm going to tell you is how do you do um, local refinements. Okay, how do you do local refinements? Okay, let's do a local refinement because here, for example, this is my study area. I want to have more cells here, but actually here I'm not very interested in what is going on. So I have to, for example, here will be 2000 the grid the refinement, while here will be 500. Okay, how I do that? I use two objects. Okay, so for example, here I will do an object, okay, inside, do any object inside your first object, and this will be of the 500. This will be 500. You change color, okay, and that's it. Okay, so what how this will work? That this object will define a grid cell size of 500, okay, and then just press OK. If you have just press OK, type yes 8 because then what the next step that we have to do is that we have to go to the original polygon and change the grid cell size to 2000 to the original refinement. Okay, so if you're here with me, type yes 8. Okay, great. So just type OK, and then we go back with the red arrow. With the red arrow, we go back here, do double click, and then we come back to the original grid cell size 2000. Yeah, 2000. And then see how it works. If we generate the grid again, we calculate the grid automatically. This has happened. Okay, you will have 2000 as an outer refinement, and then you will have 500 as an inner refinement. Okay. Mhm. If you are here with me, type yes 9. If you are here with me, type yes 9. If you have any other questions, you are always invited to post those questions on the chat. Okay, so Finally, in order just to reach what we are going to do is we are going to work with the smooth option, okay? Because here, when the smooth grid is activated, but you don't see that like in the real extension. Okay, okay, let's go back to let's select with the red arrow the inner polygon, and here we, instead of 500, we are going to develop 100. Okay, so here it will be 100. And say, is there any option to clip the grid? Yeah, there are options to clip the grid, and then we are going to discuss them on the other uh, on the other parts of the course. Okay, later on. Okay, so I think that Gabriela is there, and Gabriela can give you more information, Gibok, about what is happening to you. Okay, so just explain your problem, and then we can give you further support. Okay, so let's put 100 here. So if I generate the grid, okay, let's see what will happen if I don't smooth the grid. Okay, what happens if I don't smooth the grid is that you will pass from a grid of 2000 to 2000 to a grid of 100 by 100. Okay, so if you see, there is a big step. Okay, there is a big step in between this refinement and this refinement. Okay, and this is numerically it can be challenging, and then you could end up with some issues of convergence and so on. Okay, so there is an option to smooth the grid, and what is a smooth the grid is actually smooth the transition in between this refinement and this refinement. The it works very well, so you just have to generate the grid, but instead of, not selecting, you have to assure that this is selected, and then just type OK. And then if you have seen, the algorithm have smooth the grid in order to pass from this refinement to this refinement, but crossing intermediate refinements that brings you more stability, more numerical stability. Okay. Okay, if you are here with me, type yes 10. If you are here with me, please type yes 10. Okay, great. So I will close this. And then we are going to do the second part of this class. I won't save it. Okay. And then we are going to work with the second part. Okay, let's open another Model Muse. Model Muse. Okay, here, open a Model Muse. And what's next? Create a new Modflow model. Next. This one is only declarative. Next. Yes. And then we are going to work in Modflow 6 with 20, 23, 50, 50, and this will be alluvial. Weather rock. Este will be bedrock. Okay, 0, -10, minus 20. Okay, if you are here with me, no, minus 50, 0, minus 30, minus 50. If you are here with me, please type yes 11. The smooth refinement, yes, it allows you to have less numerical instabilities. Answering to the question of key civil. Okay, if you are here with me, please type yes 11. Anybody has problems, we will have Gabriela that is on the support. Okay, great. So anybody else? Okay, great. So here alluvial were rock and bedrock. Okay, and this is, and then finish. Okay. And this will be our model 10, 20, 20, and then we can. Okay. For this exercise, okay, because, okay, there is something else. We are going to work with Modflow NWT, okay? It's in Modflow 6, but we are going to work with Modflow NWT, okay? Why? Because in this part, we are going to define the confined methods, okay? And on the confined method, on Modflow 6, those have changed, okay? In Modflow 6, you have confined and convertible, but the confined type is by cell, while in Modflow NWT is by layer, okay? So we are going to explain that in Modflow NWT because it will be easier for you to explain this, while in Modflow 6 is more complicated, okay? And if you are, let me show you. I will I have post tutorial on that, okay? The link will be on the chat. Okay. Why? Because this tutorial reflects all the procedure how to send the confined methods in Modflow 6 that is more abstract, okay? And I don't want you to be, I want um, what it is about that you have a better first, a great first experience with numerical modeling, okay? But if you are more deep into the topic, you can review this tutorial. Okay, so let's go model selection, Modflow NWT. It shows you some recommendation, but we will see that later on. Okay, so here we have in Modflow NWT, and then we are going to work with Modflow and layer groups. Okay, if you are here with me, please type yes 12. Well, there are always few people that answer the chat. Yeah, this is normal. I mean, at the beginning, like you have more people, and some people have been lost in some steps. Just to remind you that this video will be available on the same link. So if you want to review, you are always welcome to for that. Okay, so here you have the three aquifers, but in this case, these are the layer types. So we have confined, convertible, and non-simulated, okay? So what does it mean confined? Confined is where the head is above the aquifer top, so the aquifer is always wet, is always saturated, okay? And the interblock transmissivity is calculated from the whole from the whole layer thickness, while in convertible the cell interconductivity is calculated from the wet fraction of the cell. Okay, well, in this case, and what is important to show you what is non-simulated. Okay, non-simulated is when you define is actually the name is not very clear because it's actually the horizontal flow in the layer is non-simulated. However, the layer can have vertical flow. So imagine, okay, I will do, yeah, imagine this is a model. So here you have your, for example, this will be sand, this will be sand, and this will be clay. Okay, the hydraulic conductivity of the sand will be like maybe 5 orders of magnitude bigger than the clay. Okay, so the flow that it will actually that will be actually happening on the clay layer will be minimal. Will be, how is the word? Will be I don't remember the word. Unappreciable. Unappreciable. Okay. Regarding to what the flow that is happening on the same layer on the top and the bottom. Okay. So it's not, the flow on the layer plane will be non-simulated. However, the flow through the layer, this will be simulated. Okay. And this is what appears here. A model layer groups, we have non-simulated, but it's the horizontal flow, while the vertical is all is simulated. So in this case will be convertible, and in our case it will be convertible. Okay, great. Okay, some options that we have here is that we can split the layer as long as we want. For example, we can divide this into 3. So if we type OK, our second layer will be divided by 3, Control Z. But I wanted that the first layer will be divided by 3. So model, layer groups, and then here will be convertible. This one will be convertible. And here on the alluvial, let's go on the alluvial discretization 3. Okay, this will split our first layers into 3. Our second layer will be also divided by 3, and our bedrock will be divided by 2. Then there is a big question: how many layers should I have? Okay, it really depends on the vertical discretization or the amount of data that you have, um, and how well you want to define the how well you want to define on the vertical direction the behavior of the groundwater flow. Okay, for example, if you are modeling a trench or like a drainage system, you will be interested to have maybe 20 layers. Okay, if you are modeling a region, if you are doing regional modeling, maybe you are enough with just 5 layers the because you are also restricted to the amount of layers, to the amount of cells of that it is advisable, or we advise to work with 500 at maximum with 500,000 cells. maybe 1 million cells, but please do not go over 2 million, even with Model Muse, because the software will crash. It will take a lot to review the results and so on. Okay, so if you are here with me, type yes. Which number? 12. Yes, for yes, 13. Yes, 13. And okay, Mario. Um, what is the meaning of convertible? According to where is the head? I mean, if the head is above the aquifer top, it will be confined. But if the head is below the aquifer top, it will be unconfined. That's the meaning of convertible, because the cell can be converted from confined to a confined. Okay. Great. So if we type OK, we will see that the first layer is being divided by 3, the second layer is divided by 3, and the third layer is divided by 2. And then you can play around with this. So you can play around with this. Okay. And then you can plot your cross section, and then you can see your 3 layers, 3 layers, 2 layers. Let's go to ModFlow time. Okay. Here, let's go to ModFlow time, because this is another very important part. So we have here, we have past layer groups, and then we go to ModFlow time, and then we are going to work with ModFlow. Okay, so what's going on here? What is going on? By default, in ModFlow and Model Muse, you are working with a steady state. What is a steady state? A steady state is the groundwater flow regimes where the head do not vary over time. So imagine that you have a basin, and then you have your piezometers, and then the level on the piezometers do not vary over time, and then these are steady state conditions. Okay, so actually the water is moving, the groundwater is flowing, but there is no change over time on the flow conditions. Okay, this is steady state. Yep. But what happens? I mean, you know that usually the conditions on the groundwater flow are dynamic, because you have precipitation, you have extraction, you have river flooding, whatever. You know that the groundwater conditions will change over time. But sometimes, I mean, when you are doing numerical modeling, you go from the simple to the complex. And what is the simple? You go from a steady state, knowing that you are doing that, you are working with a dynamic system, because then later you shift to transient. Okay, because shift to transient, later you shift to transient. I assure that your first model will be in steady, because it is easier to work on steady. Okay. Okay, Rafael asked a really great question. I say, what type of layer could be best suited for semi-confined aquifers? Okay, in groundwater, and this come from the literature and some books that say, okay, you have aquiclut, aquitart, aquifers, and some other. Okay, however, what happens is that in ModFlow, whether you have a transmissive aquifer or with high K, or that will be an aquifer, or like you have an aquitart that will be expressed as low K, and then semi-confined will be intermediate low K. So the everything in groundwater modeling is related to the K value. Okay, and this is something that you have to take into account. Okay, so here we have in the material we are going to work with 0 to 63115 2000 and 63115 2000. I guess it is 20 years in seconds. Okay, this is 20 years on seconds, and then we are going to work in just one time step. Okay, what is a time step and what is a stress period? This is a really great question. What is a time step and what is a stress period? Okay, so if everybody is listening, because this is a very important part of the of the of this class, is to define a stress period and a time step. Okay, okay, yeah. Imagine that you are doing a pumping test. Okay, and then you are pumping. The first day you are pumping 5 liters. The second day you are pumping 10 liters, and the third day you are pumping 20 liters. So this model will be divided in three stress periods. Three stress periods. Yeah. But in this day, you can define that this day you will simulate as a day, as a whole day, but you can also simulate. But this, if you were in a pumping test, this is not reasonable because you know that there is more drawdown on the beginning and then less on the end. So that's why you define the time step. The time step is the amount of time that where the stress period will be divided. So, for example, in the case of our pumping test, the first day we can select to be modeled every hour, for example. So we define it 24 time steps. So in this case, we have 20 years, but the whole 20 years will be defined as just one time step. Okay? This is for this exercise. Okay? Um, and these most of these are the knowledge of these the proficiency on this is with practice. I mean, you have to practice, you have to and reading the documentation. Okay. What is next? Okay, let's review some options of the output control. And here we have some options this is for the creation of the cells of output the output files. We have some options for the head. By default it's in binary, but you can change it to formatted text. Okay. The down it is also it's on formatted text. Yeah, you can define, since this works on Fortran, you can define the unit type. Okay, if you have wanted exponential, you wanted decimal, so, and you define how many time steps you will print out in the files. For example, if you have a complex model, you will where it creates such a big files on the output, you will define only certain types to be the files that you want. Okay. And then on Imi3D, you also define, this is for the output of the transport model. Okay, well, and I think that we have reached the end of this second class. I hope that it was very interesting for you. Step by step, we are going to work in more complex models and to develop, and the purpose of this course is to develop knowledge on the software. And as well, that's why we are covering a lot of the options that has ModFlow and ModMuse. while discussing why or how you apply this to real problems. If you have any question, please write it on the chat. For me, Hans, and for me, it will be done. I don't know if Hans, you have some comments.
Yes, Sol, thank you very much. Maybe we can see your face again if you stop
Sure.
sharing the screen.
Mhm.
I think we learned a lot again. Every time we go a step further, we learned how to set up the model, and I'm really grateful that you give this course for free to all of us. I'm also learning along with all the others that are watching. I think we had around 65 people concurrently watching. So thanks for that. Looking forward to the next one. Before we close this session, I have just a few announcements. I'm going to share a browser tab. Just wait. Because we had a big free webinar last Wednesday, and the video is available for free for you. So here you can see it. I will post the link in the chat. But it was about QGIS for preparing and visualizing hydrological data, and there's the video. And it was with Kurt Menke, Saber, Rajmui, and Craig Price. And yeah, you can get a lot of knowledge on catchment delineation, the whole procedure, and how to visualize hydrological data. But on top of that, there's also a registration possibility for a live course where you can learn more about this. It's a paid course, but you will get in a short time a lot of knowledge, and it will be live streamed also to you. So that's some option. If there will be further free events organized, I will inform you during these live sessions that we have together. So I'm going to stop sharing my screen. I will post the link in the chat before we leave. And maybe we can have a final look if there are any questions.
Let's see.
For Sol.
And says can select the first layer. Yeah, I mean, they ask if the first layer can be as non-simulated. Yes, sure. I mean, it really depends on what you want to model.
Okay, and let me post the link. Lost it. So be ready for the next session, which is already on Monday. So means you have to, if you want to work ahead, you can do that, of course, during the weekend or Monday during the day, depending on which time zone you are, and or repeat what you did with the recording, which will be available immediately when we close this stream, which is about now. So have a great weekend, and Sol, thanks again, and looking forward to the next one.
Okay,
bye-bye.
Have a nice weekend.